As I was saying, influenza viruses can alter their H and N spikes. And by altering these different spikes, they can attack the same host with influenza the next year, even though that host may have developed an immunity to a previous form of influenza. This is why you can get the flu multiple times throughout your lifetime. Antigenic shift only occurs with influenza type A viruses. This is a major shift where the H or N spikes change to form a different version of the H or N molecules. This results from recombination of genetic material within a host organism. So different flu virus strains exchange their H and N genes. However, there's also antigenic drift. This is a smaller change over time where there is no genetic recombination of new H or N spikes, but instead, this small change is just a result of simple mutations in a host cell where the influenza virus alters their H or N spikes in little ways. Both influenza A and B viruses can undergo this antigenic drift. Both of these changes, however, antigenic shift and antigenic drift, occur continually. And so the influenza A and B viruses are constantly changing year to year. This means that new vaccines are constantly required year after year. If these changes didn't occur, a single flu shot once in your lifetime would be enough to give you lifelong immunity to the flu. How do we know what kind of shift or drift has occurred in order to develop a new flu vaccine every year? Well, this is a result of the World Health Organization and many other health agencies working with over 100 surveillance sites around the world to gather information about which influenza A and B viruses are currently circulating in tropical locations. Remember, tropical locations don't have a flu season, and so based on the flu viruses that exist in these tropical locations in the summer, the World Health Organization and other health agencies make a determination about which influenza A and B viruses are most likely to cause infections in temperate zones in the next winter. This allows for vaccine manufacturing to begin production for the following flu season. Generally, this production begins, in fact, in February, the year before the next flu virus is made. Considering that this is an assumption and an educated guess that's made by these health agencies almost a year in advance, it is not surprising then that depending on the year, some flu viruses become dominant strains around the world that are unexpected antigenic shift or drift results from these flu mutations. Even when the match is not perfect, however, there's usually some cross protection. And so while some flu vaccines can be only 50 or 60% effective, they can still help people fight off the disease and survive, whereas in other cases they may not have. It is, of course, recommended that everyone gets the flu shot every year, because this reduces the number of infected individuals, thereby reducing the transmission of the virus itself and reducing the number of sick people every year in the United States. This very simply saves lives. But especially important are older individuals, the very young, and pregnant women. The very young and pregnant women have a suppressed or reduced function in their immune system, and as a result are much greater risk of dying from the influenza virus. Older individuals not only have a reduced immune system to fight off the flu virus, but they are also more susceptible to secondary bacterial infections, possibly including fatal pneumonia, as a result of flu infection. This is why many physicians prescribe antibiotics to older patients who have the flu, not to combat the flu, but to combat the potential lung infections from these secondary bacterial infections. While we would not prescribe any antibiotics to combat the flu, there are some antivirals that act specifically against influenza A and B viruses. These include zanamivir, otherwise known as Relenza, oseltamivir, which is Tamiflu, and peramivir, which is otherwise sold and marketed as Rapivab. The antiviral drugs do not prevent infection, nor would they eliminate completely the flu after a day or two. Instead, they are designed to be taken within 48 hours or 2 days after the appearance of symptoms, help alleviate the disease itself, and help you overcome the infection a little bit faster. Next, we're going to talk about coronaviruses. Coronaviruses are a diverse group of viruses that infect human beings and a wide range of animals around the world. They can exchange their DNA quite readily within a single host, and as a result can generate many different forms. In animals, coronaviruses are usually quite severe and can cause respiratory symptoms, gastrointestinal issues, liver issues, and neurological disorders. In humans, coronaviruses are generally mild upper respiratory infections. However, there were 2 instances that were seen recently that led to many people thinking that coronaviruses aren't as naive or easy to overcome as you would think. And this includes SARS and MERS. SARS was more common almost 20 years ago in 2002 and 2003. When SARS became more common in 2003, it was quite a major concern of the World Health Organization and the global population at large. Because what eventually came out was that about 10% of SARS patients developed severe complications and died, a fairly high mortality rate for this virus. The outbreak first occurred in a rural area of China in 2002, but the People's Republic of China ended up covering up the extent of the problem, delaying public health intervention and allowing the virus to spread much more rapidly and far and wide. SARS eventually spread across some 37 countries around the world and created such a scare that thermal checkpoints for the detection of passengers with fevers were recommended by the World Health Organization at certain airports. Some of these thermal detection cameras are still in place today. SARS is spread by close personal contact and respiratory droplets, but also transferred by touching fomites. Diagnosis of SARS can be quite difficult because it has symptoms just like the flu. And there is no specific treatment available for SARS. There's also no vaccine. Bats are the natural reservoir of SARS, and the SARS virus was found to be transmitted from bats to the palm civet cat. These cats are for sale at live animal markets in areas of China where these civet cats are purchased for consumption. Nowadays, there are restrictions on the sale of civets, and we know a little bit more about SARS and how it was formed. Similar to SARS was the development of MERS. MERS evolved and was noticed by the medical industry in 2012. MERS stands for Middle East Respiratory Syndrome, and unlike SARS, it took quite some time to transmit from person to person. So in 6 years, it's only infected a little over 2,000 individuals. However, within those infected, it's killed 791 of them, relating to a 35% mortality rate, which is extremely high. This virus has been noticed in 27 countries and is not easily spread from person to person, resulting in its low number of infected individuals over time. We still don't fully understand how it's transmitted from person to person, but we have found the MERS virus in dromedary camels, who are a major reservoir for this particular virus. The only hope is that it never mutates to the point where it can cause infections a lot more easier in the future, because this virus is extremely deadly.